I press the X here, come back to the real world. So the next thing we're gonna do is we're gonna kind of make a thin beam of light that comes off of the top of her head and kind of maybe melds with her a little bit. This is going to be a common theme in this lesson, and one that I think is why this lesson is going to be so fun, is that we're going to do a lot of procedural modeling, procedural volume stuff that will be moving around and everything, but it's not going to be simulated using regular fluid dynamics, because a lot of magic stuff doesn't really obey a standard way that smoke moves. So I think you'll see what I mean. I mean, you may have already again seen it from the preview, but you'll see what I mean either way. So there we go. This is going to be our inner effect, meaning the effect of this beam on her coming up from her head, and also this kind of pale fire around her. Then we'll have a medium effect, which will be the main tight swirling tornado. And then we're going to have an outer effect, which is going to kind of be the kicked up ambient atmospheric magical smoke around the outside. So dive in to inner here. Like I said, we're pretty much going to make a line. It's going to be a line, a beam line, starting from around here. I'll say this should be pretty long. Maybe like something like that. I'm going to say, I want to see where this actual origin is while I move it. So I'm going to say right in the middle of her neck here, something like that. So we now have a line that we're going to use as the basis for this effect. Let's resample it using the resample sop. The resample sop will take a line that was only 2 points, one at the beginning, one at the end, turn it into many points, as you can see now. It's probably too many points, so I'm going to say 0.3, so 0.3 units between each dot. And what we often want to use with resample is, let's create an attribute called curve U. There it is, first siren of the lesson, unless I didn't notice an earlier one. Let me know. Anyway, so curve U attribute is going to be an attribute that starts at 0 at the base here and goes to 1 towards the tip. And we're going to use that for various calculations, like right now. We want to control how wide. We're going to turn this into kind of a tube that will then convert into a volume. So I'm going to say, make a polywire. So a polywire has a radius, and it has a certain number of segments, or rather divisions. If you look at it, the more divisions it has, the more round it essentially looks. Segments is how many subdivisions are between each of these original points here. We don't need to change the segments. The divisions we certainly do. Let's just do an even 8 to make it an octagon. And again, the wire radius isn't going to be anywhere near this big, so 8 will be more than enough for this to seem pretty round. Now, if I want to control the width to be different at different points in it, I can use an attribute here instead of just one literal number. So let's make a wrangler before this. And we'll use that curve U attribute that I was just talking about so much. So let's make an attribute called width. This really could be any attribute, but I'm going to call it width. So we'll say the width is going to be the curve U. So nothing happens if I do that, though. So I'm not actually telling this to use that attribute yet. That's why this can be any attribute. But now if I put width here, you can see curve U is 0 at the beginning and 1 at the end. So there you go. It did exactly that. I want to not have that, though. I want to have some more control over it than that. So I'm going to say let's pipe this rather through a ramp attribute, or a ramp parameter. So I'm going to say ramp width, that thing. And so that will take a 0 to 1 value as input and return a 0 to 1 value that will just be depending on what I have here. So of course, whatever I design here is what we'll see there. That's pretty cool. I would say in our case, let's just have it be, let's have it go, really? It's like a kind of a bulb on the bottom here, right? These dots, though, should be B-splines. A B-spline, so a linear interpolation between the dots is, of course, a straight line. Or if not, I shouldn't say of course, but it is. So it goes a straight line from here to here and here to here. B-spline is much more cool because it makes a much nicer curvy curve. So there you go. Now it kind of looks like an airplane wing, maybe. So that's looking more interesting already. I'm going to say let's have this be even tighter here. This one can be right around there. Maybe I'll make it a little bit wider. But I think that's probably good. Well, I also don't want it to go down to 0. I want this to come down to just a little bit of width so that there's always some width. But this is essentially, we just designed the profile, essentially, of this shape. Meaning, if I look at just one side of this, it looks like that, doesn't it? There you go. So I'm going to go back to show all objects. So now you can see we've kind of have it blending into her head. As you can imagine, this will also be a bright volume once we start rendering it. But first, it's polygons for now while we're designing it. But to that end, let's make it into a volume. So VDB from polygons. VDB, as you know by now, is a volumetric representation that can be either a sign distance field or a surface or distance VDB, or turn that off, turn this on, a volume. And there you go. We now have made our own volume. Not the first time we've done that, certainly, but definitely not going to be the last time either. I'm going to preemptively make a VDB combine because in the next chapter, or maybe the next 2 chapters, we're also going to kind of have a little bit of a flame effect coming off of her. And I want to combine both of these effects into one. So I'll say maximum.